All right, guys. So I'm Mr. Bertel. Those who have me in integrated science obviously know me, but those in the other two classes might not. So it's good to be here working with Dr. Merrill. So today is our heat capacity lab, Dr. Merrill. Okay.
Yep.
So we have two different types of metals. Okay, what do we have in there?
Copper and stainless steel.
Okay, copper and stainless steel, and this is a calorimeter. Okay, calorimeter measures heat transfer.
Well, okay, so I want to point out one thing to our students. I'll zoom in on this. Mr. Bertel is simultaneously measuring two different temperatures. The hot water bath is the red temperature. You can see it's close to boiling. Okay? So when we put the metal in the calorimeter, we will assume that it is at that temperature. So right now it's looking like we're right around 98.7. And the starting water temperature in the calorimeter appears to be about 29.3. Now before he starts, tell them how much water you added.
Oh yes, in the calorimeter there is 230 milliliters, 230 mLs.
Okay, so what we're going to do here is we're going to just monitor the one of the bath, and we're going to do it as a function of time. Okay, so go ahead, Mr. Bertel.
Okay, so I'm grabbing the stainless steel piece of metal first. I need to just grab it by the hook here. Go around.
What hands?
It's not that easy. There we go. All right. Stainless steel.
And he's going to put it in the
Putting
calorimeter.
in the calorimeter. Make sure that I do it right this time. Doesn't stay hooked. I think we're good.
Oh, you need that straw piece on there, the spacer.
Straw piece on, and good. All right. We're not
Okay,
hooked.
so we are in there, and you can see that the temperature should be rising of the water. That little dip down was when he pulled the thermometer out of the water to get the metal in.
Teacher error.
Yeah. And we want to wait until the temperature steadies out. And believe it or not, it's close to being steady. It's starting to go down now, so 31.2 was the top temperature. Okay, now what we're going to do is Mr. Bertel is going to take that piece of metal out and set it on the counter. And we're going to see if the water temperature is steady enough to proceed. Because the calorimeter is insulated. It looks like it's sitting right at about 31.1, so I think we can go and add the piece of copper now.
We're good?
Yep.
Let me do that. I'm going to grab the piece of copper. Okay. Firm grip.
No, lift by just the stirrer. Yep.
Yeah, I was grabbing the straw last time.
Okay, and we're going to go back to the temperature, and he's going to stir that. Oh, we can see that its temperature is going up again as that piece of copper transfers its heat to the water in the calorimeter. So we want to watch to see when it levels off. Keep stirring. It's got the 32.5. And I think, I think that's it. I think that's as high as it's going to go. Okay, so what we're going to do is we're going to take these out and weigh the two pieces of metal.
Am I good to take out the copper?
Absolutely.
Okay.
You want to dry them off. Let me grab you a paper towel. We don't want to weigh the water. Reach. Okay, the
have the
balance
stainless
is zeroed out. Let me see if I can position this so we can, oh, we can read it now. It's perfect. So go ahead and put them on one at a time.
Okay, so we started with the stainless. I'll go with the stainless.
So the stainless steel piece weighs 56.5 grams.
56.5 G. Okay.
And the piece of copper,
So you see it's zeroed out, which is a good thing.
that one is 56.5 grams of copper too. Well, wait, are they the same density? Hold them side by side.
Get a good look. Just want to put them here.
Ah, okay. So they're the same mass, they're the same diameter. Stainless is bigger, so the copper must be more dense. Awesome. Okay. Okay, so what we're going to do, guys, is you're now going to do the calculations to determine. I can come in the camera here.
Yeah, sure.
Here we go. Just slide over that way. So, you gotta be down or they can't see us. Okay, so what we're gonna do in this experiment is we added thermal energy to these two pieces of metal in the bath. And then we transferred that thermal energy to the water. So we know the starting temperature of the water, and we know the ending temperature where the water and the metal were the same temperature. So we know the change in temperature of the water, and we know the change in temperature of the metal. We take the difference between the hot water bath and the equilibrium temperature, okay? And we know the mass of these pieces, and so we're going to use our equation Q equals mc delta T to determine the amount of heat that moved. And we obviously know the amount of thermal energy that transferred from the metal to the water is exactly equal to the amount of thermal energy that the water gained. All right, that's all the data we need. Have a good day.
Thanks, guys.